All right, let's take off into section 2 here. So let's get into the marine aspect here. So marine aquatic ecosystems are vital in the world. They matter mucha. So you can keep in mind that the Earth is mostly covered with water. And so as a result, there's a lot of both ecological and economic services that aquatic ecosystems provide. So scientists have run some estimates on these marine ecosystems, and they guess that about $12 million or $1 trillion in goods and services are provided every year by this. Keep in mind that is far more than terrestrial ecosystems, 70% more. So over here on the left is a list of some of the things, both economic and ecological services that are being provided by marine ecosystems. From nutrient cycling and absorbing of CO2, it moderates our climate, of course. It manages waste for us. It affects how storms like hurricanes and stuff affect us. It provides habitats and nurseries for small organisms. It provides us scientific information and genetic biodiversity. It provides us food and pets food too, but we get pharmaceuticals from it. There's places for transportation involved. There's places for people to live and recreation for them to do, and employment opportunities. Oil and gas deposits are in that. Minerals are present, and building materials. So you can see that all of the stuff that it does for us, it's really important for us to understand them and be able to utilize them appropriately. So the first thing that we want to talk about is coastal zones. Coastal zones, of course, along the coast are really vital. They are very high producers of biodiversity and all of these services we just talked about. What is a coastal zone? It's warm, it's usually nutrient rich, and it's shallow waters that are just off the coast. And so if you picture a side view of an ocean, kind of a landscape, the land kind of comes down over time and then dips off. And so if the water line comes out here, there's an area where the land is kind of a shallow ocean area, and then it dumps off into the deep ocean after that. And we're talking coastal zone, this place that's still on what we call the continental shelf, theoretically a shallower area of water, and we'll see that later on coming up here. But that's what we're talking about, coastal zones. Coastal zones are only 10% of the ocean, not very much, but most of the organisms live there. 90% of all the marine species live in there. And that means it's a very important place when it comes to water and wetland kind of habitats. But just as importantly, that is humans live in high population along coastal areas. So we are disturbing that area more than any other area. So it's important that we pay a special attention to coastal areas when we work with aquatic systems. Estuaries are the next thing here. An estuary is a place where freshwater and saltwater are mixing with one another. These are usually at the end of river systems. So here's a river running out, and when it starts to spill out here, all of this area, and here's estuary. And so typically freshwater comes in. It's lighter than saltwater because the extra salt makes the saltwater denser, and so the freshwater floats on the surface and the saltwater sits below. And so estuaries, rivers, mouths, bays, salt marshes, and then mangrove forests, which I mentioned that they were part of each other before. And so these are very highly productive, a lot of biodiversity, and they play important roles in ecosystems in general. And so here's a look at what they do specifically. So what does a coastal marsh or an estuary do for us? Well, first of all, it filters tons of pollutants. It absorbs extra plant nutrients. It takes care of sediment problems and other pollutants. So it's kind of a sponge and a filter along the coastline, which is really important. Next thing it does, especially the mangrove forests and stuff, it creates a barrier that protects inland from big storms and tsunamis. So if we have a storm pushing in, a hurricane and a tsunami, it'll hit the mangrove forests, it'll hit these barrier areas, and it will not be able to push inland like it would naturally and destroy habitat inside. So it plays an important role there. And of course it provides both habitat and food for all kinds of different species. Then within this kind of concept, you have the intertidal zones. These are places where in between tidal, in between the tides. So between low and high tide, specifically, are these areas on the shoreline. And so at sometimes they're flooded with water, as you can see here, and other times they dry up and they're dry. And so creatures that live here have to be able to have a balance between those two. They have to be able to handle huge temperature changes between cold water and warm sun, between dry and moist, different levels of salinity and wave action. And so they're very specialized creatures. They have great gripping power. They have solid outer surfaces, things like that that make them specially adapted for this unique environment. From that, we move out in the water just a little bit further and we get to coral reefs. Coral reefs are extremely important because they're one of the most biologically diverse places on the planet. They are what they call the rainforest of the ocean because there's so many different things available within coral reefs. They are both in the tropics and the subtropic areas, and they're very important. They help maintain water temperatures because of their growth and how they handle water flows and all that kind of stuff. They're home to tons of biodiversity. 25% of all marine life resides within just coral reefs. Now, here's the problem with that. We got some issues with coral reefs. There's some big problems with them. First of all, they're hugely biodiverse, and so that's why they're really essential for us to know and take care of. They do all kinds of services for us, moderate temperature of the water and the atmosphere above. They protect from erosion and coastal damage from storms and stuff. They provide habitats for things. They support fishing and tourism. They provide jobs, and they're important for studying and understanding the ocean. Within that, though, we are messing them up. So we're doing a lot of degradation, and there's been declines in pretty much every coral reef on the planet, and that's come from a variety of reasons. Pollution is creating problems for them, people standing and interacting with it the way they shouldn't, overfishing of those areas because they're plentiful, so we do that. Changing of the ocean water temperatures has had a huge impact. Coral's sensitive to those things, and it causes what they call coral bleaching, which is this where it's all just turning white and dying. And then, of course, any changes in the acidity of the ocean can create those problems. And acidity can be generated by changes in temperature or other chemical interactions that we're doing. And it actually literally dissolves the coral away, which is shown down here. And so we have to be careful because all of our coral reefs are currently under threat on the planet. Moving on here, I'm trying to cover things quickly for you. When we talk about, then we move further out in the ocean, we're now in the deep ocean zone, or the deeper ocean areas. And so when we get out there, there's actually 3 zones that we pay attention to. Euphotic. The euphotic is up at the very surface where light can penetrate. There's usually not a ton of nutrients present there, but there is a ton of oxygen dissolved in that water. And so as a result, there's a lot of photosynthesis that happens in the euphotic level. You go below the euphotic level and you get a dimly lit layer so light kind of penetrates it, which means there's not very much photosynthetic activity happening. There are zooplankton present that are eating stuff, and fish live here. The fish live here, they go up to this one, they eat, and then they come back down here for protection. And so the Bethel zone is that middle one. Then you go down the abyssal zone, and this is down deep, deep in the ocean. This is where there's not a lot of water present at all. So it gets really uber cold down there. There's not very much oxygen present, and so that dictates how much life can exist there. But it is extremely high in nutrient levels, extremely high. A lot of dead and decaying stuff that a lot of dead stuff that can't decay is down there. And so as a result, it sits on the bottom and builds up over time. The important thing is, as we have ocean currents and stuff, we will actually take some of this nutrients and we'll push it up to the surface with big ocean currents like the ocean conveyor belt, creating upwelling. And this upwelling is really important, providing nutrients up here to the top. Remember, this is nutrient low. And so it provides it to stimulate photosynthesis. And that's what's pictured right here. So you can see that your euphotic levels right here at the top. That's where most creatures live. It's about down to 200 meters. You see this continental shelf I talked about, and then it drops off and goes into the deep ocean. These are those coastal zones we talked about just a little bit ago. And out in the ocean, you get the euphotic, where all the light can get to, and you get this photosynthesis happening. The The Bethel zone right here in the region is where a lot of the fish and stuff live, and then they head up here to eat. And then the abyssal down here is the deep, dark, dangerous world way underneath there, and these are below 1,500 meters. That's it for this section. Tune in. We'll move forward.